Hey guys, welcome to another video. So in this video, I'm going to introduce a very important equation, and that equation is called V equals to F lambda. And this is the most important equation in waves. It's basically speed equals to distance divided by time. Okay, so we're going to have a look why. So first, I'll write down here V is speed of a wave. And then F is the frequency of a wave. The unit is hertz, and this is meter per second. And then the lambda is wavelength. Which is meter. Okay, so let's have a look. How do we have this? Where does this equation come from? All right, so we've learned in mechanics, speed equals to distance divided by time. Right? Okay, and then if I say this, if I say the time, I'm going to define it as one period. So for one period, so how far is the distance the wave is going to travel? So one period, the wave is going to go up and down and like that. So if we say if one period it goes up and down and like that vibration, and the wave will be this length. And this length, the distance it traveled is actually going to be one wavelength. Okay, for one period, vibration can create one wave. So the travel is lambda. So now the distance is lambda. Okay, so and then from what we've learned on the previous lesson, 1 over t, that is the definition of frequency. So now this would equals to F frequency because it's 1 over t and then times this lambda. So now this is where this equation comes from. V equals F lambda. Okay. So how do we use it? There's many ways of using it. So let's use this one as an example. Okay. Say now it's given us a red light and blue light. And what's the difference between a red light, blue light? You might say, oh, the color is different. Yeah, but why the colors are different? It's actually because the wavelength and the frequency are different, okay? All right, so I have a constant number of here. The speed of light, this is always constant number. Speed of light, we use a symbol C. So it's basically speed V, but because of the speed of light, it's very special, we use V. That equals to 3.00 10 times 10 to the power 8 meter per second. And this is how fast the speed of light is, okay? And I want to find out, well, what is the frequency of red light and what is the frequency of blue light? So what we can do is we can say, well, V equals to F lambda. I'm going to put the blue one. I'm going to do the red one first, okay? Red one here, okay, speed is 3 times 10 to the power 8. That equal to frequency times wavelength. Wavelength, the red light wavelength is 700 times, this is nanometer. So nanometer is 10 to the power of -9. Okay, if you can't remember anymore, have another look. So nano is 10 to the power of -9. Okay, like milli, 10 to the power of -3. Micro, 10 to the power of -6. And this is nano, -7. Okay, and then you can rearrange it. So the frequency equals to, say, 3 times 10 to the power of 8 divided by 700 times 10 to the power of -9. Okay. And then you can put that in the calculator. So I'll put it over here. Say 3 divided by 700. Okay, so that equals to 4.29 times 10 to the power of, that's 17, 16, 15, 14 hertz. Okay? And then I can do the same thing with the blue light. Say I want to find out the blue lights. So V equal F lambda. I put the thing here. All right, V is 3 times 10 to the power of 8 equals to frequency. Okay, I don't know frequency for this one. And times the wavelength. So blue light wavelength is 450 times 10 to the power of -9. Okay, and then rearrange. F equals to 3 times 10 to the power of 8 divided by 450 times 10 to the power of -9. Okay, if you put that in the calculator, 3 divided by 450. Okay, that equals to 6.66 times 10 to the power of 14. this is the difference between a blue light and red light. You can see the red light have a bigger wavelength, and red light have a smaller frequency. Okay, from this equation, we will actually be able to tell. Okay, if we take this away, say V equal to F lambda. Speed stay the same, both of them have the same speed. Red light have a bigger wavelength. If it has a bigger wavelength, the whole thing need to equal to each other, stay the same, and then the frequency must be smaller. So red has a bigger wavelength and a smaller frequency. Okay, if it has a bigger frequency, and then it will have a smaller wavelength, and vice versa. So this is how powerful this equation is. Basically, we can use it to calculate. Once we know wavelength, we know the frequency. Once we know frequency, we know wavelength, as long as we know the speed. Okay. If we don't know the speed, we know these two, we can calculate speed as well. So commonly, speed is the one we know. For example, as the sound travels in air, sound travels in air is 330 speed equal to 330 meter per second. Okay, and sound travels, say, if in metal, it travels at, say water first. In water, sound travels at 1,500 meter per second, and in metal, it actually travels about 5,000 meter per second. Okay, so the speed of something, we can know it. Once we know it, we change the wavelength, and we can change the frequency as well. Okay, all right. So for this and all of these parts, so please write that down into your notes as well. So that will be able to help you to solve a lot of the other questions. Okay, all right. So have a good day. I'll see you guys in the next video.